Predicting the future has always been difficult, if not downright impossible, and this is especially the case in our complex modern world. On the one hand, we face a multitude of impending disasters, from climate change to resource depletion. Yet on the other, we see rapid technological progress, innovation, and reasons to be hopeful wherever we look. It often feels as if the future could tip either way. But what if there were clues as to where we might be headed? And what if those clues were written in the stars? We have been looking to the skies for answers for thousands of years, and probably for as long as humans have been around. And as our understanding of the sheer, unimaginable scale of the heavens has developed, so too have our expectations of what we might find out there. And the most obvious question that such a vast universe poses, that has most captured the imagination of scientists, filmmakers, conspiracy theorists, and anybody with even a vague curiosity in life, the universe, and everything: are we alone? In 1960, astronomer Frank Drake began the first and to date most serious attempt to answer this question, scanning the skies for ET with radio telescopes, looking for messages sent out by distant alien civilizations. He also devised the first logical method for estimating the total number of alien civilizations we might expect to find among the 100 billion stars in our home galaxy, the Milky Way, known as the Drake equation. In the decades since Drake's pioneering first steps, astronomers and physicists have been able to place ever more precise numbers in Drake's equation, helping us to refine our estimates as to how many cosmic neighbours we may really have. And for the most part, the number seems to be converging on, well, a lot. Even using very conservative assumptions, the number still comes out at around 10,000. On top of that, many of these intelligent species may have had millions or perhaps billions of years to develop advanced technologies, including the ability to travel between the stars. By all accounts, the Milky Way galaxy should be teeming with galactic empires of all flavours, and the Earth itself ought to have been visited and colonised long ago. And yet, we see nothing. The first person known to have asked the question, "Where is everyone?" in this context was Italian physicist Enrico Fermi, and the paradox of seeing nothing when ET should be everywhere bears his name. Now, since, dozens of solutions to the Fermi Paradox have been suggested, from the weird to the depressing to the downright chilling. There is the zoo hypothesis, a Truman Show-like scenario in which humanity is encased within a galactic wildlife reserve, in which aliens are supposed to observe us from a safe distance for the purposes of entertainment or experimentation, or both. The thinking here is that aliens might be actively avoiding revealing their existence to us in case that would ruin our natural habitat, or perhaps until humanity crosses some sort of technological threshold. Hence, we don't see any aliens. There is also the more popular idea of the Great Filter, a kind of cosmic barrier that prevents technological civilizations from progressing beyond a certain level of complexity. Perhaps an inevitable nuclear holocaust following the discovery of atomic physics, or environmental disaster in the form of an asteroid impact, or perhaps climate disaster, or some combination of the above. This also resolves the paradox, as again we would expect to see no galactic empires. But this idea is slightly more terrifying, because if this barrier lies ahead of humanity, that's pretty bad news. The rare Earth hypothesis, on the other hand, posits that humanity may have already passed through its Great Filter, but we still don't see anything because we are, in fact, completely, really, totally alone. Rather than there being 10,000 civilizations in our galaxy, due to the incredibly specific conditions on Earth that are here assumed to be necessary to give rise to intelligence of any kind, we're the only ones that made it. If we really were alone, that would of course, again, resolve the paradox and give us forever nightmares. One thing all of these solutions have in common, however, is they don't really dispute one fairly big assumption that Fermi made when he asked his question. Namely, that alien civilizations, great filters and cosmic zoos aside, can and should develop and expand like we do, exponentially. And this brings us to the sustainability solution to the Fermi Paradox. First proposed in a 2009 paper by researchers Jacob Hack-Misra and Seth Baum at Pennsylvania State University, the sustainability solution challenges the idea that alien civilizations should be expected to develop at breakneck speed and spread rapidly among the stars. In particular, the authors point to the fact that ET, like humanity, will inevitably face resource constraints to its expansion, slowing or halting any incipient stab at galactic domination, or even prompting collapse in the event of alien civilizations overshooting in their growth. In other words, aliens must either choose, or somewhere along the line be forced in the face of practical limitations, to keep to a sustainable scale. Aliens stay local, don't colonize the galaxy, and are therefore very difficult to spot, hence why we haven't seen them yet. And a glance at our own history lends support to this idea. Most glorious, expansive human societies such as the Roman or Mayan empires grew rapidly to a size that they couldn't possibly sustain before slowly falling back in on themselves due to something less glorious like soil infertility or debt. The authors also point to the difficulties that aliens would face in maintaining a galactic empire should they ever actually get there, based on nothing more than the laws of physics. Picture this. Let's imagine that in the future we go beyond settling Mars or the clouds of Venus and place a colony on a planet orbiting the nearest star to our sun, Proxima Centauri. Now, Proxima Centauri is about 4 light years away, which means that it takes 4 years for light, radio waves, information of any kind to get from here to there, and 8 years for a round trip. So if the colonists get there and decide to do their own thing, A, we wouldn't find out for 4 years, and B, if we didn't like it, then tough, no more empire. Try scaling that up to hundreds of stars and you get the picture. Even if they could overcome resource constraints on their home world or within the confines of their own solar system, alien empires might be limited to spreading to a few stars at best before the whole thing just stops because it's so impractical. Now, this doesn't rule out detecting or making contact with these civilizations, but if the sustainability solution holds, it does narrow down what we should perhaps be looking for. Rather than hunting for alien megastructures like Dyson spheres, giant arrays of solar panels that are supposed to surround a sun and feed power-hungry civilizations, we'd maybe do better to focus on more subtle signatures, such as particular chemicals in the atmospheres of exoplanets, or looking for tiny alien probes that could even be littered around our own solar system. But the more important question, of course, is what are the implications for us, for the future of our species, should the sustainability solution hold? The odds are we aren't alone. And if we don't see what we expect to become out there already, the odds are we're not headed that way. We will probably never become a galactic empire, and may never even visit other stars ourselves, though almost certainly not for lack of trying. In the end, if we can't rely on constant growth to safeguard our future, it underlines the importance of learning to live sustainably on the only home we have. And that does not mean that we cannot continue to explore, to innovate, to learn about this incredible universe that we live in. Colonization is not the same thing as curiosity, just as expansion is not exploration. Success, after all, for an intelligent civilization in our galaxy may look like balance and wisdom, and we do well to head that way ourselves.